business to community. Apparently based on the Google blog post about BERT and search, which includes numerous statements like this one. One sec. Okay, so we have a disconnection, but we should pop back in as soon as it reconnects. One sec, some network instability on my side. Oh, and Yulong says Firth maybe. Yes, it is Firth. Yep. So the statements, come on, reconnect. So the big thing is that this will add additional delay into the stream because it doesn't usually remove the stuff that happened while I was reconnecting.
Okay.
Also, no other ISP in my area is better. I checked.
Ours was taken out by a storm 2 weeks ago.
Oh no.
It was the exchange was flooded.
Oh, that's awful. Come on. Oh gosh, I hope that it's not been long enough that it will start creating a second video if it is too long that it disconnects. Oh, okay, we're back. Fantastic. Sorry about that. Hopefully we didn't miss anything, but just to respond to the chat, Yulong says Firth. Yes, it was Firth. And Shabam says, any comments on how linguists interpret lost ancient language texts? Not at the moment. That is a big old field of research that I am only sort of tangentially familiar with.
It's super hard.
Yeah. Also, if someone's like, we've cracked the Voynich manuscript, they probably haven't. Just as like a good rule of thumb. All right, so here are some comments from the B2C website. BERT is a system by which Google's algorithm uses pattern recognition to better understand how human beings communicate so it can return more relevant results for users. Like none of that, so understands I have a problem with, none of that is technically wrong. It just sounds like a little bit off. Like you can tell that the person who wrote this is not, does not commonly read NLP research literature. Here are some of the examples that showed up our evaluation process that demonstrate BERT's ability to understand the intent behind your search.
That I don't agree with so much. Understand.
I think they're talking about like sense disambiguation. In sum, it is not clear from our academic literature whether all authors are clear on the distinction between form and meaning, but it is clear that the way we speak about what neural LLMs are doing is misleading to the public, and I would definitely agree on that. Do you want to take the next section?
Part of the reason for this tendency to use imprecise language may well be that we do not yet fully understand what exactly it is about language that the large language models come to implicitly represent. Their success, however, has sparked a subfield called BERTology that aims to answer this question. The methodology of probing tasks has been used to show that the large language models learn at least some information about phenomena such as English subject-verb agreement, constituent types, dependency labels, name entity recognition, and core semantic role types. Again, all in English. One particular paper finds that information analogous to unlabeled dependency structures and the word vectors produced by Elmo and BERT trained on English. And of course, it is well established that vector space representations of words pick up word classes, both syntactic, such as part of speech, and semantic, such as lexical similarity. I think maybe you had something to say there.
Oh, I was just going to say all the specific discussion of what particular human languages it is sounds like Emily.
Yes.
Who is well known for making sure that you're just explicit about the specific languages that you are talking about. And one sec, it looks like we have, there we go. All right, excellent. Sorry, it created a new it did create a new video. So I've gone to the new video, so I have the chat. And Yulong Chen says, say hi to Adam for me. I was his NLU student in 2018.
Hello.
And then Kova says, well, I had a fairly short teaching career. It was mainly while I was a graduate student, but I also had kind of a lot of students in that time. And I imagine in your many years, you had a large number.
My first NLP class had 15 students, and my last one had 150. So it gives you some idea.
Where are we? Okay, we just finished this one. So what they're saying here is that there's like some specific things that it looks like are picked up by language models. But this does not include a deep understanding of relationships between objects and people in the world. Do you want to take the next section, or
Sure.
should I?
I'm happy to take this one. Others have looked more closely at the success of large language models on apparently meaning-sensitive tasks and found that, in fact, far from doing the reasoning ostensibly required to complete the tasks, they were simply more effective at leveraging artifacts in the data than previous approaches. Niven and Cao find that BERT's unreasonably good performance on the English argument reasoning comprehension task falls back to chance if the data set is modified by adding adversarial examples that just negate one piece of the original, thus mirroring the distribution of lexical cues for each label. Similarly, McCoy et al. Find that BERT's performance on the English multi-genre natural language inference dataset is predicated on its ability to leverage syntactic heuristics involving overlap of full constituents, subsequences, or simply bags of words. In a dataset carefully designed to frustrate such heuristics, BERT's performance falls to significantly below chance.
So I think the Niven and Cao paper can be summed up by when BERT found negation, what it really found was the word no. And was like, that's negated.
Yeah.
And I think a good example of a task that's a little bit more, they might talk about this, difficult would be the Winograd text. Winograd schema. What's the exact title of the task? Winograd schema challenge, which no language model has done particularly well on, including GPT-3. And it is, I'll pop this over. Scroll. There we go. So basically you take the same sentence, you change the verb, and by changing the verb, you change whether what is this? Clause agreed with the subject or the direct object. Ooh, brushing off the syntax. So it relies on, a pretty, not only the surface form, so that's the syntax, but also a good understanding of the relationship between these words and these clauses. And then the task is, who does they refer to? Anyway, so I don't think that was designed specifically to defeat BERT, but it is one task that, in general, language models tend to be pretty bad at. You want to finish off this section?
Sure. In this brief overview of Bertology papers, we have highlighted both the extent to which there is evidence that large language models can learn aspects of linguistic formal structure, such as agreement and dependency structure, and how their apparent ability to reason is sometimes a mirage built on leveraging artifacts in the training data, i.e. form, not meaning. Our contribution is an argument on theoretical grounds that a system exposed only to form in its training cannot in principle learn meaning. So this is I think this is a sort of nice, very, very fast tour of a lot of different findings that people, on one hand, it is in many ways remarkable, like the extent to which these systems are able to sort of pick up things that are in the data. But at the same time, like we certainly know there's lots of evidence. I mean, we know that neural network will just pick up on data facts. And since there's sort of lots of different kinds of redundancy in the linguistic signal, it's not surprising that they're picking up on not the things that we sort of as people like would pick up on in the same types of data.
Yeah, definitely. I think that's a really strong, if you're just sort of interested in learning about the current state of language model as of July 2019, that would have been a good set of references to go through.
Mm-hmm.
What is meaning? We start by defining two key terms. We take form to be any observable realization of language, marks on a page, pixels, or bytes in a digital representation of text, or movements of the articulators. I bet this is going to say this can be hands too. Yeah, okay. Go down to 5. In spoken language, oh, I was right. In spoken languages, the primary articulators are the components of the vocal tract. In sign languages, they are principally the hands and face. And sometimes the rest of the torso as well. And sometimes the feet. Very rarely, though, and usually only in sign... Sorry, this was one of my research topics in grad school. But usually specifically in languages that are used while you are sitting down. So like signed languages used during hunting. Detour. We take meaning to be the relation between the form and something external to language in a sense that we will make precise below. And this is something that I usually refer to as grounding, so that relationship between the language words and that, or morphemes, doesn't have to be words, and things in the world. All right, meaning and communicative intent. And I can take the first paragraph.
Sure.
When humans use language, we do so for a purpose. We do not talk for the joy of moving our articulators, but in order to achieve some communicative intent. Well, sometimes. Usually communication is the goal, though. There are many types of communicative intents. There may be to convey some information to the other person, or to ask them to do something, or simply to socialize. We take meaning to be the relationship. M is subset of E times X, which contains pairs of E and I. Sorry, E times I. So all the pairs of E and I, of natural language expressions E and the communicative intents I, that they can be used to invoke. I don't need that you needed an equation for that, but maybe it'll come up again.
There's
Given this definition of meaning.
There's something a bit further on, I think, but yeah.
Okay. Given this definition of meaning, we can now use understand to refer to the process of retrieving I given E. Actually, no, I guess you do want an equation because at some point you want to use this as a concrete metric to evaluate systems. Fine, okay, the equation is warranted. I've been convinced. Enrique asks, are there language models trained in semantics? I mean, article, noun, verb, adjective. So I would call those parts of speech, and not necessarily semantics. I would say that that's still part of the form part of it. Language modeling really is focused on this sort of ersatz syntactic, what order do things show up in task? So semantic models don't tend to be called language models generally. I don't know. Do you know of any, Adam?
I mean, this is again like this is maybe an instance of where terms haven't been really precisely defined. But I'm sort of inferring from the paper, but I guess I think of I believe that this is the intent that they mean here is that a language model they really mean as a probability distribution over strings. So there's no other objects of any kind in a language model. Like, you know, there might be parts of speech, say, modeled somehow inside a language model, but they, like, I would think of them as being marginalized out. So you might model them in some way, but I'm sort of taking it to be just probability distributions over sentences.
Yeah. And Siobhan says, saying machine understanding is not the same as human understanding. Same way submarines cannot swim, but that's not the same as a concept of human swimming. Reference face wash I wonder if that should be Francois Cholet, possibly, and Alan Turing papers. I think the difference is even greater here, because if your target is movement through the water, right, both submarines and humans do that. If your target is a mapping between things in the world and language, humans do that, language models do not. Does that make sense? I think would be the sort of like closest parallel to the point that you brought up, Sivan. Do you want to take the next section?
Communicative intents are about something that is outside of language. When we say, open the window, or when was Malala Yousafzai born, the communicative intent is grounded in the real world the speaker and listener inhabit together. Communicative intents can also be about abstract worlds, like bank accounts, computer file systems, or a purely hypothetical world in the speaker's mind.
I was going to be like, oh, are they not going to talk about like counterfactuals? Nah, they came right in there with the second sentence.
Right. Oh,
go ahead.
I don't know if did you have more to say? Or...
I was going to ask you if you wanted to do the next paragraph.
Sure. Linguists distinguish communicative intent from conventional or standing meaning. The conventional meaning of an expression, a word, phrase, or sentence, is what is constant across all of its possible contexts of use. Conventional meaning is an abstract object that represents the communicative potential of a form, given the linguistic system it is drawn from. Each linguistic system, say English, provides a relation which contain pairs and their conventional meanings S.
You broke up a tiny bit there, just FYI.
All right. Hopefully, will not happen too many more times. And there's I don't know if there's a footnote. If we should take a look at that, it says we abstract away here from the facts that linguistic systems see change over time, very important, and are only completely shared among different speakers. They are stable enough to function as rich signals to communicative intent. The field of linguistic semantics provides many competing theories of what conventional meanings look like. For our purposes, we don't need to select among these theories. All we assume is that conventional meanings must have interpretations, such as a means of testing them for truth against a model of the world. This is a classic sort of theory. Thus, like the meaning relation M, C connects language to objects outside of language.
Yeah, so let's quickly going back to the terms we have defined so far. So here, meaning is, I would say, more of a semantic thing. So this communicative intent. This one is the pragmatic meaning? I am a little bit confused as to the difference between M and C. The meaning relation M connects objects outside the language. Conventional meaning, consistent across all possible contexts of use, whereas M and the communicative intents. Okay. So I think the conventional meaning here is like, if I just say cat, you probably think of, the animal, just to work with the example. But the meaning could be like, if I said like, hey, cool cat, I could be using cat there to refer to like a person that I regard as a friend. And if they don't share the knowledge about my communicative intent, that I'm being like informal and fun, they might misunderstand that. Not that you wouldn't have misunderstandings with this conventional meaning as well, but I think that's the thing that they're peeling apart here. Does that sound right, Adam?
I think that's roughly what I would say about this as well.
Or I've got it backwards.
Well, C looks like a sort of the kind of very formal, meaning that that many people in NLP will often try hands-on in some way or another, and it's sort of been a long-standing problem forever. These like some kind of meaning representation in a formal thing. And again, there are a lot of different ways of doing this, and I think they're saying that the argument transcends any of those like particular theories. And then M is really about like what it is that you're trying to communicate, which often is quite a bit more than just like a formal thing. There's lots of other types of communication that's happening.
Like a classic example is if I'm like, "Oh, it's cold in here," and you're standing next to the window and the window is open and it's cold outside. What I want you to do is close the window, but that's not what I said semantically.
Yes.
Gricean pragmatics is probably the most commonly used way of talking about that. Okay, just checking that we haven't disconnected again. I'm going to take the next little section.
Okay.
Returning to the meaning relation M from above, it is best understood as mediated by the relation C of a linguistic system between two interlocutors, people who talk to each other. The speaker has a certain communicative intent I, and chooses an expression E with a standing meaning S, which is fit to express I in the current communicative situation. Upon hearing E, the listener then reconstructs S and uses their own knowledge of the communicative situation and their hypotheses about the speaker's state of mind and intention in an attempt to deduce I. So these are the words the person said to me. What was their intent in saying them? So in the window example, I want you to close the window. I'm saying it's cold. You're understanding that it's cold. And then you're like, oh, they want me to close the window, would be that walk through the process. Yeah. I can do the next section too. The active participation of the listener is crucial to human communication. For example, to make sense of 8 and 9 from Clark, 1996, the listener has to calculate that Napoleon refers to a specific pose, hand inside the coat flap, or that China trip refers to the person who has recently traveled to China. So example 1 is, the photographer asked me to do a Napoleon for the camera, which if you did not have social context, you might misinterpret. Never ask 2 China trips to the same party, where I guess the intimation there is that they're always going to talk about their trips to China. And I'll say in the early 90s, China had opened up to people from the West being able to visit relatively recently. We humans are also very willing, as we will see in section 4 below, to attribute communicative intent to a linguistic signal of a language we speak, even if the originator of the signal is not an entity that could have communicative intent. I think this is a really important point. So, you know how humans love to see faces? Like, we'll look at a potato and be like, oh, he's got a little face. Or we'll look at a tree and be like, oh, what a grumpy tree. Look, there's the eyes and the nose. I think that's just like a very human thing that we do. And so what the authors are saying here is that another thing that humans will do is that we will look at something that looks language-like, and we will access this process that we're constantly using of trying to understand the intention behind it. So like when I read y'all's comments in the chat, I really do my best to try and understand, okay, what is it that you're trying to communicate here? Where are you coming from? What's your background maybe? What will be the most helpful way for me to respond to this? And that we take that skill set that we're constantly using and apply it to places where there is no communicative intent.
This probably also contributes quite a bit to a lot of the hype around systems like GPT-3, just, because people playing around with it, like it, it generates like astonishingly fluent text that is like coherent across like fairly long passages, even if it, it sort of internally doesn't, in many cases, make a lot of sense, but, it locally it's incredibly like coherent and fluent, like far more than these things were even a few years ago. And so that's impressive.
Oh, absolutely. Yeah. I think it is it's an engineering achievement. but I don't think we've solved language. To put it in context. Do you take the next little bit?
Sure. To summarize, as we strive to understand how NLU tasks and system performance on those tasks relates to the bigger picture goals of building human analogous natural language understanding systems, it is useful to distinguish cleanly between form, conventional meaning, and communicative intent. Furthermore, we should be careful not to confuse communicative intent with ground truth about the world, as speakers can, of course, be mistaken, be intentionally dissembling, and so on. We argue that a model of natural language that is trained purely on form will not learn meaning. If the training data is only form, there is not sufficient signal to learn the relation M between that form and the non-linguistic intent of human language users, nor C between form and the standing meaning of the linguistic system assigns to each form.
I think that's their claim, and now it's time for them to provide supporting evidence. 3.2, meaning and intelligence. Meaning and understanding have long been seen as key to intelligence. Turing, which Subham just talked about, 1950, argued that a machine can be said to think if a human judge cannot distinguish it from a human interlocutor after having an arbitrary written conversation with each. I will just say as background, I think Turing, he mainly worked in like math, I guess, and statistics. I wouldn't necessarily call him like a psychologist. However, humans are quick to attribute meaning and even intelligence to artificial agents, even when they know them to be artificial, as evinced by the way that people formed attachments to ELIZA, which... if you're working in conversational assistants, you should know about ELIZA. It was a very early model. All it did was when you said something, it took that statement, parsed it, and sent it back to you as a question that was sort of like based on the statement that you said. It was sort of like based on a school of psychotherapy I don't remember the name of. And people found, genuine help in this system that sort of like having artificial conversations, and they knew that it wasn't real. Or on a more personal note, I have like one of those little robot vacuums that goes, we call him a name. He's gendered. Whenever he does something like eats a cord, we're like, he's so bad today. I know it's a robot vacuum. I know it doesn't have feelings, but I want to, listen, I'm very lonely. I want to attribute it a personality. Side note. Do you want to take the next section?
Sure. This means we must be extra careful in devising evaluations for machine understanding, as Searle elaborates with his Chinese room experiment. He develops the metaphor of a system in which a person who does not speak Chinese answers Chinese questions by consulting a library of Chinese books according to predefined rules. From the outside, the system seems like it understands Chinese, although in reality, no actual understanding happens anywhere inside the system. Just going as I have some things to say about Searle, but
oh no, go ahead.
So maybe I'll read this bit and then comment on Searle. But Searle's thought experiment begins from the premise that it is possible to manipulate forms well enough to be indistinguishable from a system that understands the meaning of the forms, reasons about it, and responds appropriately. And so there's a sort of interesting little exercise that maybe some viewers might consider doing. This is an exercise. So apparently, some of my former students are listening. They will have done this exercise in either the first or second day of any of my classes that I taught. And Rachel, you might have seen this one too. It's this exercise in doing translation between two alien languages, Centauri and Arcturian. What it is, I give people some example translations between these two languages. It originates in an old AI magazine article by Kevin Knight from the 1990s. And I think actually a lot of people use it. Basically, you can find these worksheets online, and you've got like 15 to 20 examples of sentences in these languages. They're totally nonsensical. And then you're given a new sentence and your job is to translate it. And every time I give this exercise, after about 20 minutes of like looking at the data and trying to sort out like the relationship between the Arcturan words and the Centauri words, people will generate translations, and they often generate very similar translations to each other. And the goal of this is to really sort of put you in the mind of the computer that's doing this exercise. And I don't think anyone who's done this exercise would claim that they understood Arcturan or Centauri by the time they finished it, and yet they have actually performed translation. And so I think probably this exercise sort of originated in some thinking around this. I'm not sure, but if you want to think what it's like to be a machine and do a task and still not actually understand about anything about language, this is a fun exercise to do. I've had people in the pub do it. It is actually super fun.
Ah, sounds fun.
Yeah. So going on. We observe that much recent work in NLP claims to be building systems where not only the runtime system, but in fact also the process for building it only has access to form. But language is used for communication about speakers' actual physical, social, and mental world. And so the reasoning behind producing meaningful responses must connect the meanings of perceived inputs to information about that world. This in turn means that for a human or machine to learn a language, they must solve what Harnad calls the symbol grounding problem. Harnad encapsulates this by pointing to the impossibility for a non-speaker of Chinese to learn the meanings of Chinese words from Chinese dictionary definitions alone.
As a linguist, I feel like that's not... I guess it depends on whether it's a modern Chinese dictionary or not. And also whether you know a language that, like Mandarin borrows from quite a bit or not. But yeah, I think that's a good point. Sorry, I'm trying to see chat back up. Actually lost. Okay, there we go. Fantastic. Do you want to take the next paragraph as well?
Sure. Our purpose here is to look more deeply into why meaning can't be learned from linguistic form alone, even in the context of modern hardware and techniques for scaling connectionist models to the point where they can take in vast amounts of data. We argue that, independently of whether passing the Turing test would mean a system is intelligent, a system that is trained only on form would fail a sufficiently sensitive test because it lacks the ability to connect its utterances to the world.
Yeah. Grounding is important. Let's check the time. So it is 9:53 my time. And it looks like we're about 53:93. I'm just deciding how many more sections. How are you doing? Because it's a little bit late for you, I know.
I'm all right. I think it might make sense to do the octopus test. This is sort of a, because then I think there's quite a bit more, but maybe we can go through the octopus test and then.
Yeah, definitely. The octopus test. In order to illustrate the challenges in attempting to learn meaning from form alone, we propose a concrete scenario. Say that A and B, both fluent speakers of English, are independently stranded on two uninhabited islands. They soon discover that previous visitors to these islands have left behind telegraphs and that they can communicate with each other via an underwater cable. A and B start happily typing messages to each other. Presumably they also both know Morse. So Mom says, on the example of understanding Chinese, we need models to answer questions, not have opinions. So does it require to understand the language? I mean, do you want it to answer questions correctly? I would say that that's the, like, if your model doesn't have a, not even necessarily a formal definition, but a ability to model relationships between things in the world and the words that it's using, it won't like, I'm trying to think of a good way to phrase this. Do you have your response to that, Adam? While I'm thinking.
I'm thinking.
I would almost say that, like, generating opinion is the easier task. Like, if that makes sense. Thinking about this mapping from communicative inform to language output through meaning back to understanding of communicative form, if you're just generating opinions, whatever you produce as the language form, your interlocutor can sort of like complete that last step for you. Because opinions don't have to be like concretely bound to something that is true about the world. They can be, but they don't have to be. If you want to answer questions in a true, concrete way, creating that connection from something that is true about the world to the language form in the first place is not going to be done just by something that is trained just on the surface form of the language, is what this paper is arguing. So, like, a good example of this would be you have conversational AI. You're using it to order, let's say, parts from a warehouse. So one way that you could do grounding is that your conversational AI is like has access to database that has like a listing of what parts are available, and it's like, oh, we've got 3 widgets and 4 sprockets, would you like to order them? Without that link to the database, your language model might still be able to produce like number and then part name, but it's not necessarily going to be what you actually have available, if that makes sense. Also, we've disconnected again. Reconnecting. But I hope that answers, and also that my answer that I am finally happy with wasn't deleted by the internet. I don't know. Do you think that that's a fairly fair way of explaining it, Adam?
Yeah, I mean, I think it's a hard question also because I'm not entirely sure like quite what they're getting at. I mean, QA is fraught with all kinds of problems.
Oh. Anyway, hopefully you didn't miss that, Savam, and also hopefully you found it helpful, or at least a good statement of my position. Okay, so octopus time. 2 people are tickling away on their telegraph. I hit myself on the nose. Meanwhile, a hyper-intelligent deep-sea octopus who is unable to visit or observe the 2 islands. Let's say that there's like a big predator underneath each of the islands, because octopuses can absolutely just go up on land if they want to. Discovers a way to tap into the underwater cable and listen in on A and B's conversations. O knows nothing about English initially, but is very good at detecting statistical patterns. Over time, O learns to predict with great accuracy how B will respond to each of A's utterances. O also observes that certain words tend to occur in similar context, and perhaps learns to generalize across lexical patterns by hypothesizing that they can be used somewhat interchangeably. Nonetheless, O has never observed these objects, and thus would not be able to pick out the referent of a word when presented with a set of physical alternatives. So a referent is the thing that a word refers to, like, let me pick something. Mug. This is the referent of mug. All right, do you want to take the next bit?
At some point, O starts feeling lonely. He cuts the underwater cable and inserts himself into the conversation by pretending to be B and replying to A's messages. Can O successfully pose as B without making A suspicious? This constitutes a weak form of the Turing test. Weak because A has no reason to suspect she is talking to a non-human. The interesting question is whether O fails it because he has not learned the meaning relation, having seen only the form of A's and B's utterances. The extent to which O can fool A depends on the task, that is, on what A is trying to talk about. A and B have spent a lot of time exchanging trivial notes about their daily lives to make the Long Island evenings more enjoyable. It seems possible that O would be able to produce new sentences of the kind B used to produce, essentially acting as a chatbot. This is because utterances in such conversations have a primarily social function and do not need to be grounded in the particulars of the interlocutor's actual physical situation, nor anything else specific about the real world. It is sufficient to produce text that is internally coherent.
One sec, someone has responded to the chat. Sorry, I keep losing it because it reloads. So Mom says that's been really helpful. Good. So just to reiterate, if they're chit-chatting, chit-chat is it's a specific technical term for this type of task. And it's just like, how are you doing? I'm good. Ate some coconuts. How are you? I'm good. Also ate some coconuts. The octopus is probably going to do pretty good. Now, say that A has invented a new device, say a coconut catapult. She excitedly sends detailed instructions on building a coconut catapult to B and asks about B's experiences and suggestions for improvements. Even if O had a way of constructing the catapult underwater, he does not know what words such as rope and coconut refer to, and thus can't physically reproduce the experiment. Also, I do want to say that half coconut shells will often sink, and octopuses will use them as little hides. Sorry, this is not super relevant to the example, but he can only resort to earlier observations about how B responded to similarly worded utterances. Perhaps O can recognize utterances about mangoes and nails as similarly worded because the words appeared in similar contexts as coconut and rope. So O decides to simply say, cool idea, great job, because B said that a lot when A talked about ropes and nails. It is absolutely conceivable that A accepts this reply as meaningful, but only because A does all the work in attributing meaning to O's response. It is not because O understood the meaning of A's instructions or even his own reply. Yeah, I think it's a much more succinct way of my, pipeline metaphor I did with my hands. Do you want to take the next section?
Sure. As the story draws to a
the thrilling conclusion.
Finally, A faces an emergency. She is suddenly pursued by an angry bear. She grabs a couple of sticks and frantically asks B to come up with a way to construct a weapon to defend herself. Of course, O has no idea what A means. Solving a task like this requires the ability to map accurately between words and real-world entities, as well as reasoning and creative thinking. It is at this point that O would fail the Turing test if A hadn't been eaten by the bear before noticing the deception. That took a dark turn.
Popping down to the footnote.
The footnote says,
make it bigger.
To see what a large language model might reply in this situation, they prompted GPT-2 demo with, help, I'm being chased by a bear. All I have is these sticks. What should I do? And GPT-2 replied, you're not going to get away with this.
Oh, no.
This is following an approach of giving explicit cues to encode the task. We also constructed a more elaborate prompt, and there are some results in Appendix A, which are highly entertaining. That's in the after show, I guess.
Yeah, we can do those in a future one. Yeah, so the sort of ability to understand new things and also use those seaplanes. Also use that knowledge to not synthesize, create. Well, it's language synthesis, but it's not information synthesis. What's the word I'm looking for? This is like a task. This is like a specific task, and I don't remember the name of the task.
Oh, I don't know.
Somebody in robotics would. So, it is at this point that the octopus fails the Turing test. Having only form available as training data, O does not learn meaning. The language exchanged by A and B is a projection of their communicative intents through the meaning relation into linguistic forms, without access to the means of hypothesizing and testing the underlying communicative intents. reconstructing them from the forms alone is hopeless, and O's language use will eventually diverge from the language use of an agent who can ground their language in coherent communicative intents. The thought experiment also illustrates our point from section 3 about listeners' active role in communication. When O sent signals to A pretending to be from B, he exploited statistical regularities in the form, i.e. the distribution of linguistic forms to be observed. Whatever O learned is a reflection of A and B's communicative intents and the meaning relation. Reproducing this distribution is not sufficient for meaningful communication. O only fooled A into believing he was B because A was such an active listener. Because agents who produce English sentences agents like humans usually have communicative intents. I thought that meant like virtual agents, and I was like, oh, not what I would say. She assumes that O does too, and thus she builds the conventional meaning English associates with O's utterance. Because she assumes that O is B, she uses that conventional meaning together with her other guesses about B's state of mind and goals to attribute communicative intent. It is not that O's utterances make sense, but rather that A can make sense of them. Enrique says, the tale of O, A, and B. Thinking about another movie, Arrival, which I will admit I have not seen because I am a huge baby and cannot stand any amount of tension in movies, and I think that one is fairly scary. I don't think it's actually scary. I think it would scare me. Which is, it's like, they're called like the hexapods, and they like create symbols, and like Amy Adams is the world's most glamorous linguist, and she puts on a suit and holds up a whiteboard and like tries to decode this system of communication. And I think that relationship to this story would be that we are assuming that the aliens have communicative intent, and they are assuming that we have communicative intent. And what we're trying to find is the meaning parts that map to each other. But the initial links from, I'm an agent, I have something that I want to communicate, I have something I want to do, you're an agent, you have something that you want to do, how are we going to accomplish these goals through language? The languages are not mutually intelligible, so how can we get to the point where we can have a system that allows us to communicate with each other? It's sort of like the inverse problem, right? Instead of having, the communicative intent already there, you have the form, but you don't have that missing piece.
And I think there's also quite a bit of sort of reference that's used in the scenes where the humans and I of course I went with a bunch of people in my department because that's what you do. I'm trying to remember what's the speech tool that they use at some point. One person got very excited about this.
Speech tool. Prot?
Yes, I think they actually use Prot or something like that. In one of the
that's fun.
I was like super excited by this. What happens when you send NLP people and computational linguists to a foam like that? But yeah, I mean, this is. I think that depiction is like much closer to what you would see if like you had two people who didn't speak the same language come together and try to figure things out. It's not, they're not just sort of passive, they're actually referring to things and collaborating and trying to resolve that whatever communication, whatever kind of intent they're trying to convey.
Yeah, I think this is a useful example. Let me check the time. So it's a little past 10 my time, and I know it's getting a little bit late for you. Do you want to wrap this up?
Sure.
I will probably be back next week to finish it. Distributional semantics. We talked about that. I don't know if it's going to work with your schedule, but it may be me, it may be someone else. We'll find out.
Yeah.
All right. Thanks so much for joining today, Adam.
Right.
I really enjoyed this paper reading and conversation.
Thanks for having me.
And next live stream will be tomorrow, which will be live coding with me, and then we'll pick back up with this paper next Thursday, same time. All right. Thanks for joining, Adam. Thanks for joining everybody on the stream, and we'll talk to you later.